Welcome to question number 8 here. This is stoichiometry. We're solving chemistry questions, stoichiometry to begin with right now. Alright, so here's question number 8. Before now, there have been 7 other videos, 1 through 7, solving questions on stoichiometry, so you can go back to check them. Straight to the question at hand. 25 grams of methane reacts with excess oxygen according to the equation. That's the equation. What mass of water is produced? Alright, so the first thing you want to do here is to ensure that your equation is balanced. If it's not balanced, then you have to balance it, okay? You don't want to work with it unbalanced so that, we don't run into problems. Okay, in our case here is balanced, so that's really good. Now the next thing we're supposed to do here is to figure out the molar mass of methane. Are you ready? So CH4, using the relative atomic mass given to us, that's going to be 12 plus 4 times 1, and that gives you how many? That's 16 grams. Okay, so after doing that, we also need to figure out the molar mass of water as well, H2O. We also did this one in the previous video, 2 times 1 plus 16, and that gives you 18 grams. So that's the molar mass. So I have written it grams this way because I'm explaining. If you're writing it without explaining, make sure you write grams per mole here, like this, /mole. So that means grams per mole is the unit, okay? Or you write it out by saying 1 mole of methane is equal or equivalent, if you want, to 16 grams. So this is also correct. Alright, what do we do next? We have 25 grams of methane, so let's start our conversions here. 25 grams of CH4. Is there a way we can take that to moles? Yes, we're going to use something that relates mole and grams of CH4, okay? And that would be this one right here. So we'll take that. Do we place the 16 up or down? We have to place the 16 down because we really want the grams of CH4 to cancel out, okay? So you see how easy this stuff can be. And then 1 mole would stay up here. Now we've converted that to moles. The next thing we want to do is to relate our moles of CH4 to the moles of water, and that you can get from this equation here. 1 mole of CH4 gives you 2 moles of water, so I need to convert it to moles of water. So I want to take out the moles of CH4. So I have to bring 1 mole of CH4 down here because of this 1, and then 2 moles of water up here because of the 2 that's over here. So that's your mole ratio you're using now. Alright, so moles of CH4 would cancel out moles of CH4. Again, we've successfully converted to moles of water. Alright, so are we ready to take it to grams now? What do we do next? There has to be a relationship between moles of water and gram of water, which you can get from the molar mass. So multiplying this out, you also multiply it with 18 grams per mole. So how do we use that? Do we write 18 grams up here like this and put the 1 mole of water down here? Would that be right, or should it be the other way? Well, the way to find out is if it cancels. So 1 mole of water cancels out the 2 moles of water here. I'm talking about the unit, and then you know you're doing the right thing, okay? So let's compute all this now. If you do your multiplication and division correctly, you should have 56.25 grams of H2O. Does this make sense? Let me know in the comments. Before you go, one more thing. If you have 25 grams as this is the value you're given in the question, right? And that's the only thing we can see here. Don't worry about the relative atomic masses. Leave that. Focus on that 25. 25 there is 2 significant figures, right? 2. means that your final answer should also be two significant figures. Alright, I would encourage you to watch more videos so that you see how these significant figures work and how you know the best way to leave your answer. This is correct, but depending on the kind of professor or teacher that you have, they might want you to make sure everything is done really precisely. So we're going to leave it in two significant figures as well, since this is the only thing we have and is in two significant figures. If you had more than that, just look for the one with the lower number of significant figure. Okay, so two sig figs here, we have about 60. So that's about 60 grams of H2O. So this is also acceptable, and that's it. Alright, so thank you for watching. If you found this video helpful, give it a like, comment if you have any questions or concerns, or if you have anything you would like us to address in the future. You can also tell me where you're watching from, and I'll be glad to connect. Alright, I'll see you later on question 9. For now, take care and bye-bye. So if you're rounding 56.25 to 2 sig figs, it's going to be 56, alright, not 60. Alright, so I thought I would chip this in while going over the video again, before posting. So if you have not already observed that while watching, and if you already observed that while watching, let me know. But please take the correction. It's going to be 56 for 2 sig figs and not 60. Alright, so who knew already? Let me know.